Hello and good evening to those who's watching this video. I do not know why some of you are here to watch my subpar and poorly prepared video presentation, but if you are here to stay, you are more than welcome. You see, this week has been a packed one, packed to the absolute max. Tight schedule, multiple assignments to submit in 1 week, a test for me to prepare, and so much more. So if you notice that my voice sounds a bit scuffed, it's probably because I'm recording myself reading this script while feeling a bit sick at 3 AM. That's basically your average uni experience. We all been through this. Nevertheless, allow me to introduce myself before I forget. My name is Ahmad Kamil bin Abdulrazak and I'm your today's host for this video. Or any other video that comes out of my channel, that is. Assuming I will pump up new videos, which I will not. Today's video we will talk about bounded buffer problems in operating system. Before we start understanding what is a bounded buffer problems, I will introduce you to our sponsor for today's video,
Raid Shadow Legends.
Nah, I'm just kidding. Let's start with process synchronization because I feel it's important to talk about it briefly before we start the main topic for this video. The reason is, bounded buffer problems are one of many classic problems of synchronization. So, what is process synchronization? To summarize, it is a critical part of operating system design that allows process allocate resources without obstructing with each other. What that means is, I don't know, but think of it like an airport's runway. You got planes taking off on a separate runway and there are planes landing on a different runway. So what you got is a systematic runway. Now, if both takeoff and landing share the same strip, and we got planes do its things at the same time, well, in short, planes go boom. Just like process synchronization. Now, when processes do have access to the same pool of resources, this can lead to data inconsistencies. There are a lot of factors that can cause these issues to come about, like race conditions, hardware and software issues, or deadlocks. That's not really important, for now at least. You get the idea. Thus, bounded buffer problem is born because synchronization processes somehow manage to screw it up, just like my first relationship. And no, there is no second one. So, what is a bounded buffer problems? I don't know, but imagine you play Minecraft, which I know you don't, but if you do add me on Hypixel. Anyway, imagine playing Minecraft and you have this thing called an automated farm. Now, to break it down, there are three components of an automated farm. You got the farm that produces goods, then you have the buffers that keeps your goods in a temporary containers like chests or hoppers. These containers have fixed buffer size. Then you have the consumers, which is you, the player, because you might want to do something with those goods. I don't know, maybe for trade, to eat, or to craft things with it. You get the gist of it. So, in a nutshell, when you got something is close to a bounded buffer system. The producers create items or data and place them in a buffer. The buffers acts as a temporary storage with fixed buffer size, and the consumers consume the data from the buffers. So, what is the problem? Well, first thing, buffers are shared between both consumers and producers. What that means is, if the consumers tries to consume the data while producers produce the data at the same time, and both processes obstructing with each other, you will have a system screwed up. This can lead to data inconsistency or just plain data error. The second thing is, if the buffers are full and the producer keeps on piling data on the buffers, it will result in data losses, which is something that you probably need in your system. What if the buffers are empty and the consumer tries to consume either way? I wonder what will happen. That's why it's important to have a systematic synchronization mechanism. So, how do we fix it? Easy. Not really. To fix it, we'll make use of the semaphore solutions, and those solutions consist of both binary and counting semaphores. Now, here's how it works. From here on, I will be using terms that probably doesn't feels familiar, but bear with me. Let's look at producer's pseudocodes to help us understand it better. This is the pseudocode. Seems a bit mouthful, but I'll break it down for you. What this pseudocode's really yapping about is basically the producer will wait until there is at least one empty slot. Then it decrements the empty semaphore, and the producer is going to insert data in one of those slots. Then it acquires lock in the buffer so that the consumers can't hit it with devious leak until the producer finishes its job. The lock then released and the value of full is incremented because the producer has just filled the slot in the buffer. Same thing for the consumers, but the other way around. Simple as understanding the current geopolitics around the world. Probably much more simpler. Then there you have it. Problems has been solved. It's not as complicated than I expected, but given how much I dislike reading, this is bearable at least. So for those who have stayed till the end watching this video, I don't know why would you sacrifice a whole 50 minutes of your time, but I thank you. Heck, why not give it a thumbs up and subscribe to be part of the Coomer gang? So anyway, that's the end for this video, and until next time, I see you soon. Bye bye.